All right, in this video, we're going to take a look at solving sides and angles using tangent. So up until this point, we've solved for the ratios or set up the ratios, sine, cosine, and tangent ratios, but actually that all serves a purpose. That purpose is to solve for pieces inside of right triangles. So we're going to look at tangent today. So just to review, remember SOHCAHTOA. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and then tangent is opposite over adjacent. So remember when we set those up, the hypotenuse is opposite the 90 degrees, the opposite side is opposite the angle that we're talking about. And we're going to see how that works out here. All right, before we move forward, this is an important piece of information. You need to make sure that your calculator is in degree mode, okay? When we're doing problems from these sections, sine, cosine, tangent, you must have it in degree mode. Now, how do you check to see if your calculator is in degree mode? Well, if you're using like a TI-83 or a TI-84, something like that, you're gonna have to hit the mode button, okay? So it's near the top, at the middle it says mode on it, and you're gonna go down until you see it should probably have radians highlighted. You're going to go and highlight degrees. If you're using Desmos, let me go ahead and show you what it's going to look like on Desmos. All right, if you're at the Virginia Desmos, it should automatically be there. If you're just at the regular Desmos site, what you're going to need to do is go to this little graph settings. You're going to want to make sure that the degrees is set up. If you do not have degrees set up, you're going to get all the wrong answers, okay? And it's going to be frustrating and confusing, and you're not going to understand. So make sure your calculator is in degree mode. If you're getting a ton of wrong answers and you think you're doing it right, that would be a good place to check. All right, so let's move forward here. How do we use tangent to solve for triangles? So remember that tangent, so in this case we're talking about x, is the opposite side over the adjacent, where O is opposite the angle I'm talking about. So let's look at this example. They ask you to solve for the value of x. So this is what we're going to do. We're going to start by labeling our sides, right? That's going to be number one place to go. So just like before, this is going to be my h side, right? So let me set this up real quick. Sorry. All right, here we go. So that's going to be my h side, right? Now this is the angle I'm talking about, right? I'm talking about this 27 degrees. So the opposite side is going to be over here, and then my adjacent side is going to be right there, okay? So notice how we did that. We did the hypotenuse, opposite, adjacent. We should be pretty good at doing that by this point. All right, now let's go ahead and set this thing up. So I know that tangent is equal to opposite over adjacent. So I'm going to set it up tan, and then again, of my angles, so 27 degrees is equal to opposite side over adjacent side, x over 14. Okay? Now I want to solve this for x, right? Now look guys, this is really important. The 27, that's always going to be my degrees, okay? If we see degrees, that's going to be going in the parentheses. Also, it's tangent of 27. We are not allowed to separate the tangent and the 27, and we're not allowed to just multiply the 14 into the 27, okay? That is its own separate thing. So when I multiply by 14 on both sides, okay, the 14 comes out front here, okay? And I end up with 14 tan 27 is equal to x. So what am I going to plug into my calculator? I'm going to plug in 14 tan 27. I'm going to do it into Desmos here. So 14 tangent, and notice when I do tangent, it changes the font to say that's a function. 14 tan 27, and I get 7.1333. So we're just going to round this to the nearest tenth. All right, so let's take a look. Let's make sure our answer makes sense. So I got 7.13, so I'll say 7.1. Now, does that make sense within the sense of this problem? If this A side is 14, the O side is 7, that seems to be reasonable based off the picture. You can't tell for certain, and since we're always going to get these weird decimals, it's good to look at your picture to make sure it makes sense. All right, let's look at this next one. Okay, let's scroll down so we can actually see what we're doing here. All right, Come on. There we go. All right. So in this case, let's go ahead and label our sides. Now I'll give you a hint. It's going to turn out to be tangent because we're doing tangent for all of these, right? All right, so this one right here, that's going to be my O side. This is my H side here, and my A side over here. All right, so if I'm going to set this thing up, I've got, I'll just do this inside the triangle actually, tan 60, inside parentheses, is equal to my O side, 19.2 over my X side. Now be careful. Notice, in this case, my X is actually on the bottom. On my last problem, it was X was on the top. Okay, X is on the bottom this time. Okay, so what does that mean for my problem? Okay. What it means is that when I solve this problem out, I can't just multiply both sides by 19.2. Notice, I need to multiply both sides by X. So I get X tan 60 is equal to 19.2, okay? Because we're just doing some algebra here. So I'm going to divide both sides by tan 60, so I end up with, I'll put this over here, X is equal to 19.2 divided by tan 60. Okay, so don't just assume, okay, every single time I'm just going to plug the degrees in, and then I'm going to go ahead and solve this thing out by dividing tan of the angle by whatever number shows up. Okay, we actually have to set up the problem each time, and then that tells us how to solve the problem. Now, again, where a lot of people go wrong is like, well, I don't want to set it up. Okay, I just want to plug it in my calculator. Well, I understand, but it's good practice to set up the problem so that way I can make sure that when I'm solving this out, it's solving out correctly. All right, so let's plug this in. I've solved this out for X, 19.2 divided by tan 60. So we're going to plug that into our calculator. 19.2 divided by tan 60. Oh, there we go. And I get 11.08. So that would be roughly 11.1. Okay, and let's see if that makes sense for my answer. With 11.1. And sure, that's smaller than 19.2. Now look, tangent doesn't always make it smaller. In these particular situations, it happens to be that case. Okay, but take a look at your triangle, make sure it makes sense. All right, let's do one last one here. And this problem is actually a little too large. Let's see if we can shrink this down a little. All right, let's see what we can do. All right, that should work. Here we go. All right, now guys, this one's going to be a little bit different than the ones we've done in the past. Notice that I have both of my sides, right? So when I set this up, again, this is my H side, that's my O side, that's my A side, okay, because I'm talking about this angle right here. Okay, so when I set this up, it's tangent of X, okay, because it's X degrees, right? So X is going to go inside my parentheses, and then it's going to be O side 4 over A side 9.1. Now, tangent is a function. That means we need an inverse function to get rid of tangent. So what I'm going to do is I'm going to do tan inverse on both sides. Now this looks complicated, but actually it works out really simply. Okay, so I'm going to do tan inverse on both sides. So that's on that side, and then I do the same thing here, tan inverse. Sorry, it's rough to see. All right, tan inverse and tangent cancel out, so I end up with X is equal to tangent, and notice the -1, okay? If you're trying to get tan inverse on your calculator, you're going to hit the second button that's in the top left corner. It's usually a different color, and then your tangent button, and you'll get your tan inverse. So tan inverse of 4 over 9.1. Okay, so second button, then tangent gets you the tan inverse with the -1 up there in the corner. All right, so this is what I'm going to plug into my calculator. Now, there is a keyboard shortcut for this, but let me show you another way to get there. You can hit your little show keypad and come over here to functions, and notice here's our tan inverse, okay? There's probably a shortcut to it, but it's probably just faster to just go to your functions and do it that way. And then it was 4 over 9.1, right? So 4 over 9.1, and we end up with 23.7. 23.7 as a final answer. All right. Now, does 23.7 make sense for this problem? Well, it does because we're dealing with an angle. We're not dealing with a side, okay? 23.7 degrees. That does look roughly accurate for the size of that angle. Now, if you got like 82 degrees, that would be a problem, okay? But in this case, it's small, it's acute, should be around 30 degrees, somewhere like that, so 23.7, thumbs up. All right, so that's how we're going to solve problems for the tangent ratio.